Hey peeps, hope you're doing well. This video will hopefully be pretty quick and to the point. It's going to discuss the half angle identity. So the first part of section 4 was about the double angles, and now it's the half angles. Basically, in short, what happens in order to derive these identities is if we were to take our half angle formulas and solve them, if we take the double angle formulas that we've already proven or derived and solve them for sine and cosine respectively, and then literally have those angles, then you would end up with these half angle identities. So there are going to be 4 total actually, but 2 of them are going to be for tangent. You can go ahead and write these identities directly on your orange reference sheet. Okay, so first one we got is sine of alpha over 2 is equal to plus or minus the square root of 1 minus cosine alpha over 2. And then we have cosine of alpha over 2 is equal to plus or minus the square root of 1 plus cosine of alpha over 2. And then we know that tangent is sine over cosine. So literally, if we were to take these two identities and divide sine divided by cosine and do some algebra, we would get this tangent half identity, which is plus or minus the square root of 1 minus cosine alpha over 1 plus cosine alpha, such that the cosine of alpha cannot equal -1. Because if it equaled -1, we get 0 on the denominator. We know that that is not okay. This tangent identity is questionably complicated. So there's also another one. If you take sine and cosine and do different algebra to it, I'll say, you can also, for tangent, have it written as the tangent of alpha over 2. Alpha over 2 is equal to sine alpha over 1 plus cosine alpha. So these are your 4 half angle identities. And there's actually another one. I want to say it might be for tangent as well. But you can get by. I kind of prefer using this bottom tangent one to the first one for obvious reasons. It doesn't involve crazy square roots. Okay, so I'm going to do 3 examples with you, one for sine, one for cosine, and one for tangent. So here's how it works. If I ask you, what is the sine of 7 pi over 2? Basically, and first thing, radians, we're just typically not as comfortable with radians as we are with degrees. So I would say go ahead and convert to degrees first. So, oops, what the heck was that? Okay, so if we go ahead and convert to degrees, that'll be 7 pi over 2 times 180 over pi. Multiply these fractions straight across, and we get 105 degrees. So the key here is on the unit circle, 105 degrees is not one of the angles that we readily know. So that's where this half angle identity comes into play. So typically with a half angle, that means this angle, 105, is half of an angle that we do know on the unit circle. So in that case, typically what you do is you're going to rewrite this 105. So first of all, sine of 7 pi over 2 is equivalent to, ooh, so sorry, y'all. Equivalent to the sine of 105 degrees. Now, the sine of 105 degrees, as I mentioned before, is equivalent to, instead of writing 105, this is the same thing as the sine of 210. So if we double 105, which to not be confused with the double angle identities, we get the sine of 210 divided by 2. So 105 is a half angle. That's the idea, right? It is a half angle, and it's half of 210. 210 is on our unit circle, okay? So a few things to note. We are trying to figure out what is the sine of 105 degrees. This is essentially our question. Even though we're gonna write it differently, it's gonna look differently, this is the question. So first thing I want you to decide every time is, where is this? Now 105 degrees is in the second quadrant, okay? So that implies sine is dealing with the y value, So that implies the y value in the second quadrant we know has to be positive. So with the whole plus or minus choice, we know we're going to choose plus. Okay, so it's already written on your orange reference sheet, but so that we're we know what's happening in our notes when we look back at them. Let's go ahead and just write the half angle identity for sine. Sine of alpha over 2 is equal to plus or minus the square root of 1 minus cosine alpha all over 2. Now, alpha is not 105, right? Your alpha is what is being divided by 2 to get your original angle. So alpha is actually going to be 210. Okay, so everywhere we see alpha in this identity, we're going to plug in 210 instead. So we're going to have the sine of 210 divided by 2, which is 105, right, is equal to plus or minus the square root of 1 minus the cosine of 210, all divided by 2. And our goal is to, figure out what is the cosine of 210 and then simplify this puppy using a good bit of algebra as much as we can, and we should get down to our answer. Now, let me take that on a side note. If you are not fantastic at figuring out, maybe you've been at the mercy of using your unit circle plate this whole time and you're not used to just kind of deriving the unit circle in your head. You're used to looking at it. Basically, here's what you need to remember. If I'm trying to find the cosine of 210, first of all, we have to note, where is 210? Well, 210 has got to be somewhere in this third quadrant. Okay, so if I want to know its coordinate points, I've got to figure out its reference angle. So for reference angles, we use alpha, 180 minus alpha, alpha minus 180, and 360 minus alpha. So if I want to choose a reference angle for 210 degrees, since I'm in the third quadrant, I'm going to do 210 minus 180, and I get 30. Okay, so you better know your 30-degree coordinates by heart. Your 30-degree coordinates are the square root of 3 over 2, 1/2. How does this relate to 210? Well, the only difference is that since 30 is in the first quadrant, both of your numbers are false. Since 210 is in the third quadrant, that means both of its coordinate points are negative. Did I just say both of the coordinates are false? Y'all, it's really late. I shouldn't be recording this video so late, but I didn't really have a choice. Anywho, if I sound weird and sound like something is maybe potentially a mistake, please make sure you ask me about it so I can clarify. Okay, 210, I'd mentioned both of these are negative because it is in the third quadrant. Now, I'm looking for the cosine, which is just the x. So that's the only thing I'm going to be substituting over here into the identity. Okay, so let's carry on now. We already established y value is positive, so I can drop off the plus or minus symbol because I know it's going to be positive. I'm going to do 1 minus the cosine of 210. We just did this side note over here to figure out. It's going to be negative square root of 3 over 2. And then all of this is over 2. So my goal is just to algebra this puppy until I get it as simplified as possible. Well, the first thing I want to do is in this numerator, so everything other than 2, I have 2 separate numbers being subtracted, and I want to give them common denominators so that I can subtract them. So I'm going to change that 1 to 2 over 2 minus square root of 3 over 2 all over 2. And that's going to be the square root of, now I can subtract these two because they have common denominators. So that'll be 2 minus square root of 3 all over 2. All of that over 2. So it's really important when you have these stacked fractions, you kind of make the main division bar, bold, because what's going to happen now is we know that dividing by 2 is the same thing as multiplying by the reciprocal of 2, which is 1/2. So if we have 2 minus square root of 3 over 2, instead of dividing by 2, I'm going to multiply by 1/2. And then I'm going to multiply these two fractions straight across. So when I do that, I'm going to get the square root of 2. How did that switch? Hold on. I missed my double negative somewhere. There it is. Okay, hold on. Let's back up a couple steps. In my original step, I have 1 minus negative square root of 3 over 2. So what's going to happen is this will actually change to a plus sign. So I'm going to have 2 plus square root of 3 over 2. And then all over 2 times 2 in the denominator is 4. Now, since 4 is actually a square number, I can take its square root. So then I can end up with the square root of 2 plus the square root of 3 all over, not in under the radical anymore, is 2 because we can take its square root. So what you're going to have to get used to is the answers to these questions can look kind of funky because you can have radicals inside of radicals. So as long as you don't have a radical in the denominator, and as long as you don't have a bunch of stacked fractions, you are allowed to have radicals inside of radicals if necessary. Okay, next let's do a cosine problem. I want you to find what is the cosine of 67.5. Well, again, the thing to realize is 67.5 is not on the unit circle. Okay, so we need to figure out how can I represent this angle using a half angle identity. Well, before I even do that, I want to say, okay, 67.5 is in quadrant 1. So that implies that the cosine, which is the x value, is positive. So when I do the plus or minus, I know I'm dealing with a positive. Now, how can I represent 67.5 as a half angle? Well, I double it. That's how I represent it as a half angle. So if I double it, I can rewrite this expression instead of cosine of 67.5 to be the cosine of 135 divided by 2, because 135 divided by 2 is 67.5. Okay, so let's recall the cosine of alpha over 2, this is from your reference sheet, is plus or minus the square root of 1 plus cosine of alpha all over 2. So very similar to the half angle for sine, except 1 plus cosine alpha. Okay, so now let's substitute in our values. We're going to have cosine of, we know alpha is 135. So it'll be the cosine of 135 over 2 is equal to, we know it's going to be positive, so we don't need to write plus or minus, the square root of 1 plus, again, using what you know about the unit circle, we should be able to determine very quickly what is the cosine of 135 all over 2. Well, I'll just keep simplifying the right side. We get 1 plus, the cosine is the x value at 135. Since it's in the third quadrant, it's actually going to be negative square root of 2 over 2 all over 2. And then similar to the last problem, in this main numerator, I want to go ahead and be able to add, or technically subtract those fractions. So I'm going to rewrite the number 1 to have the same denominator. So I'm going to write it as 2 over 2. That way I have minus square root of 2 over 2, and now both of these have a common denominator of 2, which will allow me to actually subtract them. So when I do that, I get 2 minus square root of 2 all over 2. And then that is all over this 2. So again, kind of crazy stacked fractions, but now that you have just one fraction over 2, this is the same thing as taking that fraction, 2 minus square root of 2 all over 2. And instead of dividing it by 2, I can multiply it by 1/2. And then when I multiply it by 1/2, I multiply straight across. I get 2 minus the square root of 2 all over 2 times 2 is 4. And I think that's as far as I can go. Sorry, I looked at something on my notes and it made me kind of second guess myself here. If there's an issue with this, I'll correct it, but I don't want to waste our time by me trying to figure it out mid-video. So we'll go for this. Oh, hello, I know what I did. 4 is a square number. So again, I can take its square root, so I can simplify this guy one more time by saying this is the same as the square root of 2 minus the square root of 2 all over the square root of 4 is 2, no longer under a radical symbol. So that was my issue. All right, last one will be a tangent example. And it's going to be to find the tangent of 165. So again, let's note that 165 is not on the unit circle. Therefore, I need to find an angle that is on the unit circle. And again, because this is a half angle lesson, I know that I can write it as a half angle if I just multiply it by 2. So this is the same thing as 160 times 2 is 330 divided by 2. All right, so 330 divided by 2 gets me back to 165. Now, the other thing to notice is that 165 degrees is in quadrant 2. So if that is in quadrant 2, then I know that my tangent in quadrant 2 should be negative. So, and this one's going to be, because that's slope, right? So I know tangent should be negative. Now, as I mentioned earlier, there are two identities for tangent, half angle identities. I prefer to use the simpler looking one over the other one. So I'm going to prefer to use that the tangent of alpha over 2 is equal to the sine of alpha over 1 plus cosine of alpha. Okay, alpha we know is 330 because I'm dividing it by 2 to get back to 165. So then when I substitute in my values, I get the tangent of 330 over 2 is equal to the sine of alpha is 330 over 1 plus the cosine of 330. So again, by your knowledge of the unit circle, you should pretty quickly be able to spat those numbers out for the coordinates of 330 degrees. 330 degrees is in the 4th quadrant, so I know my sine value is actually going to be a negative 1/2, but cosine will stay positive, so it'll be 1 plus the square root of 3 over 2. And then your job is just to simplify this number. So if I'm going to do that, I'm going to leave my numerator alone. It's going to stay as negative 1/2. But we're going to use the same tactic here as we did in a couple of the other examples. I want to actually be able to add those two fractions together. So if I give one a common denominator as the other number by just writing it as 2 over 2 instead, then when I have plus the square root of 3 over 2, I now have common denominators and can actually add them. So this is equal to negative 1/2 all over 2 plus square root of 3 all over 2. And then again, dividing by a fraction is the same thing as multiplying by the reciprocal. So this is the same thing as negative 1/2 times the reciprocal of the denominator will be 2 over 2 plus square root of 3. Well, 2 over 2 cancels, just leaving us with negative 1 over 2 plus square root of 3. And though it looks a lot simpler and lovely and fantastic, it's actually not done because we have a radical in the denominator and that's not allowed in math. So if I multiply it by the conjugate of the denominator, right, if we multiply by the conjugate, that means if the denominator is 2 plus the square root of 3, I'm going to multiply it by 2 minus the square root of 3 over itself. And then I'm going to multiply straight across. So my numerator is pretty much fine, except that negative 1 will change the sign of both of these. And I'm going to have negative 2 plus the square root of 3. And the denominator, you have to realize when we distribute, this is actually foiling, right? So first is going to be 2 times 2, which is 4. Inner will be 2 square roots of 3. Outer will be minus 2 square roots of 3. And last will be minus square root of 3 times square root of 3 is 3. And then if I simplify this again, I hit negative 2 plus the square root of 3. These two middle terms here cancel, right? 2 square roots of 3 minus 2 square roots of 3. And then 4 minus 3 is 1. And anything over 1 is just itself. So typically as your answer, you would probably see this more commonly written as square root of 3 minus 2. And of course it's all over 1, which just means it is itself. So that was a pretty quick example of one of each type. Again, if you wanted to use the other identity for tangent, you were more than welcome, but that one The one that we did was my preferred identity if I had the choice.